in the Iucrc Brain Initiative, which consists of the collaboration of industries, government, and academy for the creation of solutions, and we are proud to be able to host it here with all of you.
Before we begin, we would like to express a special thanks to our guest, Dr. Joseph Tedesco, Dean of the Cullen College of Engineering from the University of Houston, and Dr. Kyle Squires, Dean of the Ira A. Fulton School of Engineering from Arizona State University. It's an honor to have the presence of such eminent people in the scientific community. We thank you for accepting our invitation and becoming the main guest of today's event.
The Brain Center is a University Industry Collaborative Research Center that accelerates the impact of basic research through close relationships between industry innovators, world-class academic teams, and government leaders.
Today's event celebrates the beginning of the participation of Tecnológico de Monterrey in the Iucrc Brain Initiative, funded by Phase 1 National Science Foundation, NSF. In addition, the collaboration with the University of Houston, Arizona State University, and the network of universities that conform this initiative.
We are excited about all the amazing conversations we are going to have today. Let me remind you of the program for today's event. First of all, we will be hearing words of welcome from Dean Sartuche and also words from the invited deans. Then the directors of Brain will present their centers. Finally, as we have a schedule, we will have the presentation of the first Brain book, followed by closing remarks.
We want to hear your comments and thoughts. Therefore, after these presentations, we will have a Q&A. You can put your comments and questions in the chat, and I will be gathering the information for the speakers. Thank you for your attention, ladies and gentlemen. Now let me welcome Dean Manuel Sartuche, Dean of the School of Engineering and Sciences at Tecnológico de Monterrey.
Thank you very much, Jaime and Esther. Everyone, it is a real pleasure and privilege to have this opportunity to welcome you all to this event in which we as Tec de Monterrey and our School of Engineering and Sciences are becoming a member of the NSF Industry University Cooperative Research Center, the Iucrc initiative. And in this process, as already mentioned, consolidating our collaboration of many years with the University of Houston and Arizona State University. So I would like to express our deepest gratitude and appreciation, particularly to Joseph Tedesco. Dear Joe, thank you very much for being with us. He is the Dean of the Cullen College of Engineering at UH. And Kyle Squires, Dean of the Fulton School of Engineering at ASU. To both of you and from all of us here at Tec de Monterrey, we really, truly thank you for taking the time to be with us today. I would also like to recognize and deeply appreciate the enthusiasm, support, and trust given to our community of students and faculty here at Tec from our NSF Iucrc members from industry. Jorge Murrieta at Machine Care Industrial Services and Luis Mille at Stabilit. Thank you very much for your support and being with us today. Really, truly, we are very excited to become one more member of the Brain Initiative. Since the beginning, we had foresight this project as a unique opportunity to develop the Brain Center site here in our school. And of course, we have high hopes and expectations with this initiative. You know, very recently, we at Tec introduced a new strategic plan for the year 2025 and our vision to the year 2030. And there is a strong commitment and emphasis on both declarations that human condition, human flourishment, it's a key element in all our endeavors and aspirations for the time to come. And I truly believe that the Brain Initiative serves as a priceless tool, as a priceless leverage to help us reach such goals of putting the human being as a key element in all advances and technological breakthroughs. And this is why the Brain Center is an elite project for our School of Engineering. And we are really truly convinced that current and future solutions for not only industry and its productivity, but for many challenges that we face as human beings, for well-being and quality of life, will be tackled and solved with data and information on human conditions and behaviors provided by biometric systems, and therefore paving a way to a better future for all of us as human beings. It is also our belief that no one can reach downstream meaningful goals acting on their own, isolated and independent. And this is why we celebrate alliances, networking, and joint efforts with fellow colleagues, fellow global institutions and organizations and universities, such as this NSF Iucrc platform, in which the BRAIN initiative emerges and that brings industry and universities together for global concerns and challenges. We see networking as a strong and vital enabler to our commitment, not only to serve and outreach industry and society at large, but also for education. During the last decade, we have been moving forward to partner with many industry stakeholders, obviously outside tech, and this has been a fundamental pillar for our new educational model. We call it Tech 21, which is a challenge-based model in which we strive to expand the classroom and reach beyond where the problems and challenges are developing and truly happening. And I especially mentioned this emphasis on industry-university connection. In fact, we have designed and implemented different initiatives of collaborative efforts approaching industry in different ways, such as the launching of our hubs of innovation in our Tech Cyber initiative, the hub of cybersecurity in Mexico City, in our campus in Mexico City, the hubs of AI and data science in Campus Guadalajara and Monterrey, where we share an open platform with other universities and industry and companies that offer or require services of innovation, training, and entrepreneurship in those areas. Also, we have developed a program called Business Developers, which is a specially trained group of members of our school who are in an intensive mood, in an intensive and continuous search for opportunities with industry and other stakeholders outside our school. So taking as a whole, this project, it represents a significant strengthening of our commitment to education and service to society. Finally, I would like to especially congratulate our group of professors, particularly Jorge Lozoya, who has been instrumental in pushing forward this project and for organizing this kickoff event. Thank you, Jorge, for all your enthusiasm. And also, I would like to extend on behalf of School of Engineering our warmest congratulations to the group of professors who are the authors of the book that will be introduced shortly and whose contributions have made it possible to see this field of biometrics as one that has a very bright and promising future in our institution. Luz Maria Alonso, Ruben Morales, Ricardo Ramirez here in our school in Campus Monterrey, Pedro Ponce in Campus Ciudad de México, Hugo González in Campus Puebla, and Beli Carrion in our medical school. To all of you, congratulations and thank you for your contributions. And again, to all of you, thank you for your support and networking with us. And as we say in Mexico, bienvenidos todos, esta es su casa. Thank you.
Thank you, Dean Sertuche, for an enlightening speech on biometric signals and their importance to brain tech. I would like to introduce today's presenters, Dean Joseph Tedesco and Dean Kyle Squires, to give a few words. Now, I ask our guest, Dean Tedesco, to join us in the microphone.
Hello, everyone, and thank you, Manuel, for having me at this very exciting time in this meeting of our three great institutions to discuss the Brain Institute. Just to give you a little background information about the Collin College of Engineering. We are a public institution located near downtown Houston, and are best known for our research and diversity initiatives, as well as being a Tier 1 research institution. We are committed to serving our community and supporting global education and research initiatives by providing complex solutions to societal challenges, conducting pioneering research and scholarly work, and facilitating the transfer of new technology and knowledge throughout the world through partnerships with renowned institutions such as Monterey Tech and Arizona State University. Our ongoing major priorities in recent years has been, first of all, the hiring and retention of staff faculty, including prestigious National Academy of Engineering faculty. The Collin College of Engineering currently has 15 National Academy of Engineering faculty members. We are also making concerted efforts to recruit more women and minorities into our programs. Incentives for recruitment and retention include competitive research endowments and professorships, opportunities with industry to promote entrepreneurship and innovation. As a testament to the great quality of our faculty, we have received 23 faculty early career development awards over the past 10 years from the National Science Foundation. These prestigious awards are given to support the work of early career faculty who have been identified as outstanding leaders in their field on a national scale. We are prioritizing success rates of our student population by recruiting high quality students, fostering pipelines through a local community college partnerships, and initiating success programs such as our nationally renowned first year experience. In order to improve the quality of our graduate programs and increase enrollment, we have greatly expanded our graduate level offerings and have signed numerous MOUs, such as our MOU with Monterey Tech. The Collin College has also expanded physically, opening 2 new state-of-the-art research facilities, greatly increasing our ability to conduct world-class research. Our research enterprise covers a wide range of topics. Recent primary focus areas include the research and development of autonomous sensors and wearable devices and geomatics, diverse energy, computational data-driven information systems, engineered medicine, advanced manufacturing materials, the shaping of natural and built environments. One item of note is that more than 20% of our total research expenditures come from our partnerships with industry. Our college has made creating new and expanding existing research centers a priority. Noteworthy research centers at our college include the National Center for Airborne Laser Mapping, the Brain Center, the Hurricane Resilience Research Institute, and the Advanced Manufacturing Institute. The Cullen College is a major proponent of innovation and entrepreneurship, providing a platform for our faculty and students to take ideas straight from the lab to the market. We are able to foster this culture through ongoing initiatives and programs such as the Engineering Program for Innovation and Entrepreneurship, along with shared workspaces that promote collaboration and startup accelerators geared toward providing training and assistance. Noteworthy companies in our enterprise include Luminous, a company formed by 2 University of Houston alumni using technology developed at the Cullen College of Engineering, which focuses on smartphone-based rapid self-diagnostics. Elemental Coatings, a company focusing on developing de-icing technologies for the US military as well as private industry. Amperes, a startup focused on scaling up novel round semiconductor wires. Sensitech, which produces smart cement and tube probe monitoring systems. And of course, the great work being done at our branch of the Brain Center, including Dr. Contreras Vidal's groundbreaking work in therapeutic, robotic exoskeletons and brain-machine interface systems. Dr. Contreras Vidal's work in this area has allowed us to have numerous flourishing partnerships with other research institutions, such as yourselves, in addition to additional partnerships both locally in Houston and nationally, as well as including close ties with the largest medical center in the world, the Texas Medical Center. Partnering with Monterey Tech has created many existing opportunities between our institutions, including our MOU for student-faculty exchanges, which has already begun yielding PhD graduate prospects. Project collaboration on the Iucrc Brain Institute, and joint doctoral committees. I look forward to our continued partnership. As you're all aware, the Brain Center is one of our highest priorities at the Cullen College of Engineering. And through continued collaborations, we have the capacity to revolutionize healthcare and rehabilitation. But most importantly, we can change the lives of countless individuals for the better. Thank you all so very much.
Thank you, Dean Tedesco. Now I ask Dean Squires to give words about today's event.
So thank you so much. I will share my screen. So again, thank you so much for the invite. It's a pleasure to be here. The center has been quite successful, and it embodies a lot of the things within the Fulton schools that we really prioritize and advance and seek to grow. So very quickly, we've got a couple things about the Fulton schools to set context. And it's to not only introduce you to the Fulton schools, but also give you a sense of how the Brain Center embodies a lot of what we want to accomplish. So this is what we look like in terms of our organizational structure. So we are 7 schools that deliver 75 degree programs at the graduate and undergraduate level within a very large metropolitan university, not unlike University of Houston in that sense. So as we came into fall 2021, again, those 7 schools, we launched a new school of manufacturing that I'll briefly summarize at the conclusion of my talk here in a few minutes. We enroll over 27,000 students in engineering and technology programs. 9,000 of those kids are online, 18,000 are on campus. We graduated 5,100 students last year. We graduate the largest number of engineering students in the country, and I'll show a slide on that in just a moment. This is made possible by our faculty, their ideas, their connections with partners. That includes 32 NSF Career Awards over the last 3 years. We're about 470 faculty altogether across tenure track and lecturers. We had about a 10% increase in awards last year. So our faculty, even during COVID, were extraordinarily productive. We continue to see kind of that wave of award move into late 2021 and into 2022, meaning some activities in the lab were perhaps a bit slower, but moving. But nevertheless, the faculty had time to really reflect and think and advance ideas, and it's really paying off. The Brain Center is one of the ways in which we emphasize translation. That is, intrinsically, how does a faculty member's research meet a need, solve a problem? It could be very foundational in terms of discovery, but if there's a thread connecting it to some larger application or problem, generally those are really rich problems. One of the ways that you can assess value is how are you doing on entrepreneurial output, such as startups, disclosures, licenses, and we're doing well. Again, I'll have a slide on that to show in a moment. We're also globally connected, and this notion of partnership is very important. So again, embodied by the brain with the partner schools, reaching across countries, reaching within the US and so forth. We seek to broaden those. We have long-standing capacity building programs in Vietnam. We're part of an alliance that has launched a College of Engineering in London, and we seek to continue that process. So I mentioned a moment ago about the scale of the degree production that we have. This is a histogram of the top producers of engineering degrees in the US for 2020, 2021. Now notice here it says 3781 for Arizona State University. That corresponds to the engineering degrees. A moment ago, I said it was over 5,000. We offer also degrees in technology fields that are part of that count. Here, it's strictly the engineering degree count. And the schools that are also in that neighborhood, if you will, Georgia Tech, Purdue, Texas A&M, and so forth, UIUC, good schools, large schools, we recruit from those schools and vice versa. At this scale, we're able to really have sway, that is have impact on company expansion, major initiatives in research at the federal level and so forth by producing that much talent. So what about our research sort of enterprise? And the way to think about that is this slide is organized into 3 pillars, and it goes from left to right. Early stage discovery, right? Those NSF Career Award winners, the foundational work that might be coming from DOE, NSF, the Department of Defense, and so forth. That work, much of that work will translate. We have several IUCRCs, of which the brain is an exemplar. And it's important to, again, closing the gap between application and discovery. So here, one of, I think, the interesting facets of an IUCRC is the industry is, if you will, pulling ideas through. The faculty are pushing ideas, and the center then is that conduit to connect, to nurture, to identify, through road mapping and so forth, what are those really important problems to tackle from the center perspective. And we have a lot of that activity across several IUCRCs. We lead 2 ERCs. We have a good connection into our communities. I'll talk about that in just a moment. And then finally, mission-focused enterprises. So you can envision that some of the activity over here will, in some sense, graduate into a large mission-focused enterprise that could be at very high TRL, could be very deeply connected into a specific set of applications. You need to build up expertise and connections to be able to do that. And we, again, look at those opportunities when they present themselves. So this is a sense of our intellectual property activity across the Fulton schools over the past 5 years. So these are the numbers of invention disclosures. And you can see last year, 175, steadily growing. And one of the reasons that happens is because the faculty are very, if you will, entrepreneurially engaged. So many faculty are not going to start a company. That's certainly okay. But many faculty do have an idea such that when that discovery is made, oftentimes it makes great sense to disclose it and at least begin to start that process by which we can understand, is there a possibility of, intrinsic value through licensing, through perhaps a startup and so forth. And then we had over 100 patents issued in the Fulton schools last year and about 10 startups. We'd like to see that number be around, say, 15 or so per year, and we're approaching that. I should also add here, the numbers on this slide corresponding to the intellectual property activity of Fulton schools faculty, it represents about 2/3 of the university activity. So it's a very important component. So what about our goals as I begin to conclude? So we want to be the largest, most impactful college of engineering in the US. Broadest access, most diverse, most significant in terms of the students that we attract, the students that we retain, and the students that we graduate. We are the largest college of engineering in the US. We do produce more engineering graduates than any other college of engineering in the US. We would like to double the number of graduates that we produce to meet workforce demands in our community, in the region, and assume a genuine leadership position from the perspective of teaching and learning within universities. We also seek to achieve a significant leadership position in research that necessarily drives faculty hiring to bring on, in this case, about the next 200 faculty to advance research agendas in the tenure track ranks, full-time faculty appearing through lectures while they may, in fact, their primary responsibility is to the academic programs, professors of practice, which are another form of faculty appointment. Those individuals are very vital to oftentimes helping with, again, those translational aspects. Individuals who've come from the community, who've come from industry, and are able to really advance that. Our goal is to be responsible for half of the university-sponsored funding. Right now, we're about 25% or so. If we're driving half the university-sponsored funding, if we're the largest college within the campus at that point, we're a significant force. And we want to do that, not just to be large, but because we want to have impact. This is about driving excellence of the faculty, impact of our students' programs, and the research enterprise. We'd like to increase disclosures and patents by 25%. And again, all of this, I think, is just an example of where centers like BRAIN are so important. Okay, having success in its own right, but fitting this larger picture. So it's also very important, and again, the BRAIN Center embodies this word partner matters. The problems that we're tackling in pedagogy and research, in industry connection are complicated, and they really do necessitate very strategic partner engagement. We seek to grow those. So here again, the BRAIN Center is really a model. And we want to use that to drive fundraising, because when we drive philanthropy through, say, the BRAIN Center or others, we're also then able to give more opportunities. We can increase opportunities for students and faculty by doing that, and believe me, that's a major focus. So we see that as a very significant opportunity in terms of our goals, and so these are very, aggressive. Okay, but again, it's getting to this leadership position that we value so much. So what's next? I'll say just only one, I think I have 2 slides on this new economy initiative. It's funded by the state of Arizona to accelerate expansion of the technology economy of the Valley, growth of the Fulton schools. In many ways, we find inspiration in parts of this new economy initiative through the BRAIN Center. So the BRAIN Center is successful in its own right, but we get a lot of ideas, right? And these ideas seed other initiatives. I think that's the most important point. We want to hire those faculty. We want to build linkages. We want to expand across campuses and schools, because the opportunity for engineers, biomedical engineers, you name it, is even greater than we're currently exercising. And then we also want to seek to leverage national efforts, and we're involved in some very significant ones currently. So very briefly, The New Economy Initiative, I bring it up here because it's a new initiative within the Fulton Schools of Engineering this year, at ASU, in fact. And it's also, again, an example where, frankly, we've learned lessons from BRAIN, okay? And we seek to leverage the New Economy Initiative in interesting ways moving forward to support the BRAIN Center and vice versa. But its goals are really, this nexus of tech partnerships in Phoenix, grow our colleges, and launch these science and technology centers. Okay, and they'll remind you, okay, of the way the BRAIN is sort of set up and operating. So we have 5 on the planning process. These 2 will launch this year. These are physical places with unique infrastructure and expertise to connect to industry and university, to speed translation, to train students, to connect into workforce and build partnership. And by doing that, we can not only improve the research enterprise of the Fulton Schools and in fact the Valley, but we can spur, and this is important, job creation, startups, things that really do matter in the community. Now you can see these 3 are planned for next year. The one that is, if you will, closest in some sense to the BRAIN Center is human performance. And we're actively going through kind of an ideation co-creation process on that with our industry partners. This is what they look like. And again, the BRAIN Center, in fact, has similar, which is why I put the slide in here, kind of a similar set of objectives, right? Training, connecting into partners, thinking about how research discoveries can translate. What does that mean? And those structures are vital, okay? And in many ways, you find a lot of overlap here between a science and tech center and BRAIN. Finally, some of the other new things in the Fulton Schools of Engineering is the launch of this new school. The School of Manufacturing Systems and Networks launched on the Poly campus, which is in Mesa. And it is formally, part of the Fulton Schools this fall. We're driving hiring into that school, largely around things that you see here, right? Future of work, Industry 4.0, automation, a lot of the, the disciplinary elements that are important to the future of manufacturing. Things like data-enabled decision-making, robotics, controls, the kinds of things that will drive a lot of the future of the factory floor and beyond. We've also renamed our computing school and deliberately introduced this AI term, but it's augmented intelligence. And here again, there's a connection into BRAIN and our biomedical engineering colleagues in the sense that augmented intelligence is, I think, a used to talked about term within biomedical engineering from the perspective in that it's about advancing the human, not replacing the human, but advancing them, whether they're a disabled individual or a well individual. Our Polytechnic School, also on the Poly campus, also going through a reimagining process that is thinking about how they'll sort of recreate themselves, is also part of this process over this year as well. So I just want to say, again, thank you for the invite. Congratulations to all that the center's accomplished to this point. As you heard from Dean Tedesco, as important as the BRAIN Center is to UH, also true at ASU. So we look forward to continuing support. I'm sure this will be a successful meeting. And again, thanks so much for the invite.
Thank you, Dean Squires, for taking the time to speak at this event.
And now, for us to have an overview of the different and relevant activities we do in the center, Professor Contreras Vidal, Professor Marcos Antelo, and Professor Jorge Jesus Lozoya Santos, each of them directors of the BRAIN centers at the University of Houston, Arizona State, and Tecnológico de Monterrey, will share with us their presentations. Also, Professor Lozoya will do the pronouncement of the book edition, Biometric Systems, Technology, Applications, and Trends. Professor Contreras Vidal, welcome to Tecnológico de Monterrey and to this event. Please join us in the microphone.
Thank you very much. It's really a pleasure to be here today. And thank you, Tecnológico Monterrey, for hosting the event, and to Dean Sartuche, Squires, and Tedesco for supporting this initiative. Um, do I have control of the slides here?
Yes, could you please confirm, Professor?
Yeah, but I cannot. Can you move to next slide? I don't seem to have control. I just want to reiterate how proud I am, not only being a UH engineering professor here at University of Houston, but also a former student at Tec de Monterrey. I'm a class 87 electronics and communication. So for me, this is a way of closing the loop. So I'm very, very proud of that. Next slide. The Brain Center was founded by Arizona State University, University of Houston, but it has grown over the past 4.5 years. Now we have 2 international sites, Tecnológico in Monterrey and Universidad Miguel Hernández de Elche in Spain. And the Industry Advisory Board has approved West Virginia University and Georgia Institute of Technology to join the center. And there are plans for University of Maryland, Baltimore County, to also form a brain site in Baltimore. Next one. And just to remind you the mission, and I want to allude to what Dean Sartusha said about improving the human condition, because that's really at the core of what we do here. We are developing medical devices that are safe, effective, and affordable, because accessibility is important. And we're using this in many ways for diagnostics, for restoration, for enhancement, augmentation, rehabilitation of sensory motor, affective, and cognitive functions. And the ultimate goal is improving quality of life at home, work, and play. Next one. And to accomplish this, we believe in a synergistic, convergent research approach to the development of these neurotechnologies. At the Brain Center, team science is important. And this it's important at multiple levels, not only within the academic institutions, but also in close partnership with industry and the government. Next slide. So government catalyzes on the partnership as well as other government entities and on research that is relevant to the nations. The university provides research infrastructure, human capital, and technical expertise. Industry provides funding for research, but also insight for industrially relevant projects. I would like to emphasize that our Brain Center is focused on bridging the gap between early academic research and commercial readiness. So we are really a driving engine for translational research. Next. This figure shows the brain leadership team. The executive committee is comprised of all the site directors and co-PIs at the US and international institutions. And we communicate with the Council of Deans and university policy committees that provide valuable assistance, as well as ensure that the center attends to institutional priorities, community needs, and also regulations. National Science Foundation appointed evaluator reviews the work of the Brain Center and reports back to National Science Foundation. We have a program manager that coordinates communication across all the sites, and each site has a project coordinator that helps with the managing of all the activities within the center. We have 4 functional components: the research trust, the engineering workforce development, diversity and culture of inclusion is so important in the center, as well as promoting our innovation ecosystem. We have 2 advisory boards. One is a student-led, where we get feedback from the students about their not only the research they're involved with, but also their training and education. And our industry advisory board selects projects and guides the research activity of the center so that they are industry relevant. We have also partners, notably the Food and Drug Administration, the FDA, who is a full affiliate of the Brain Center, and we are working with them to address regulatory science for the medical devices that are emerging from the center. And we have a growing number of members from industry and foundations that are part of the Brain. Next one. We have 12 research trusts, from big data, neuromodulation, clinical trials, to how to deploy neurotechnologies for smart factories in the arts, and also in terms of sports. We have created a new trust on ethical and trustworthy AI, because that's an important area that we see growing in many aspects of daily living. And it will have an impact on the human condition. Next one. These are the members that currently part of Brain, and we're working with our industry advisory board to increase and promote and recruit more industrial members to the center. Next. And I'd like to spend some time in reviewing some of the goals of the Brain Center. We are very interested in promoting and supporting synergistic projects across the center sites. We want to promote ethical and trustworthy neurotechnologies that address challenges in society. We would like to recruit new industrial partners to support this research trust. Importantly, one mission of the center, working with industry, is to develop technological roadmaps that will guide the future research in the center and in our nations. We would like to promote student involvement and leadership so that our students become the game changers in our communities. We would like to increase the center's visibility in social media to reach out to the public for outreach purposes and to promote citizen science in the work we do. We are working on a long-term sustainability plan for the center so that after graduation in 5 years, the center activities will continue in close relationship with industry and our communities. We are promoting workforce development from K-12 to junior faculty, as well as faculty-student exchanges. And last but not least, for the Brain Center, it's very important to promote diversity, equity, and inclusion in all the activities we do. Next one. I would like to spend some time in reviewing the state of the Brain Center at the University of Houston. Currently, we have 30 faculty across 7 different colleges. So that speaks about the team science approach and the cross and transdisciplinary collaborations here at the University of Houston. Currently, we have 3 postdoctoral fellows, 13 graduate students, 14 undergraduates, and 7 high school students that are part of our teams. And we have an internal project selection mechanism that promotes industry relevance and collaboration, leading to 100% project approval by the industry advisory board. Next. I'd like to provide a brief overview of current research projects. The first one is developing the next generation of robotic exoskeletons that can be used for rehabilitation of motor function in children with disabilities. The technology so far has been focused on older individuals, people with spinal cord injury, stroke, and other gait disabilities. We think it's very important that we bring this technology to children. And there's a great opportunity here to understand at the same time how the brain develops and how the neuroplasticity in the developing brain can work together with these robotic exoskeletons and brain-machine interfaces to promote development at the sensory, motor, and cognitive levels. We are also developing high-performance technology to listen to the brain and to understand behavior of the brain in action and in context outside the lab, on the clinic, at work, at home. Next one. In collaboration with our site in Spain, we are developing new approaches to understanding the neural basis of taste, how the brain codes taste, and the gustatory cortical responses. And there's a collaboration with a company and that we are looking at the response red wines. So there's neuroscience at the intersection of preference research and marketing as well. With the Tech of Monterrey, we're very interested on detection of engineering interest in children through the use of AI and biometric signals. And my colleague Jorge Lozoya probably is going to be talking more about this later on. Next. We are also pursuing research on how we can prevent loss. Loss of balance results is one of the leading causes of disability in older population. So we are developing technology to identify and detect an imminent loss so that we can overcome that. And another project is developing brain-machine interfaces where the signals driving the interfaces are acquired at the level of the spinal cord. Nowadays, we have interfaces that are central. We get signals from the brain, or peripheral from muscle, other type of physiological signals. Here we are tapping at the hub between our extremities, our limbs, and the brain at the level of the spinal cord. Next. Some recent accomplishments are pediatric exoskeleton won a competition of the pediatric device competition of South by Southwest in Austin, presented by our student David Guren, 125K for this project. And we are also conducting research experiences for undergrads. This is a $500,000 project funded by National Science Foundation to train the next generation of neuroengineers. And last summer, we had 15 students from 9 universities, including from Arizona State, and 7 high school students. Next. These are examples of accomplishments from these students that have participated in our training programs. Our Grace McClurg from Western Kentucky University was selected and presented at the Kentucky Academy of Science. She earned 3rd place in the health science section. University of Texas Austin, Tristan Bennett was selected to present at the 12th International Conference on Applied Human Factors and Ergonomics. Next one. We also co-edited a special issue in the open access IEEE Journal of Engineering, Medicine, and Biology that focuses on standards for neurotechnology for brain-machine interfaces. I would like to invite all of you to be part of these activities, which help guide industry and innovation. Next. I mentioned that the Food and Drug Administration is a full affiliate of the member, and all sites have access to this through the Industry Advisory Board. We have been assigned Dr. Kim Hanson as our contact at the FDA for research and dissemination activities from the Brain Center. I'm also co-chairing the Industry Connections Working Group on the standards and interoperability of brain-machine interfaces. So I also welcome you to participate in this group. And we created an Artist in Residence program with support from our Dean, Tedesco. And currently, we have collaboration with visual artist Geraldina Interiano Weiss and Emmy-nominated composer and film director Amos Cochran to deploy neurotechnology to understand the neural basis of creativity. And what you see on the bottom of the picture is on the projection is the digital synthesized painting from brain activity, which coexists with the physical painting generated by the artist. Next one. And this past semester, one of our senior design capstone projects developing a soft robotic exoskeleton won first place at the Excellence in Senior Design competition held at the University of Texas, Dallas last May. I believe this is the last slide. To conclude, we have a US Brain Student Association. They have been working closely with our student group at Arizona State, and we are looking forward to interact with the students at Technological Monterrey. And with this, I'd like to pass the mic to my colleague, Marco Santello, who is the rector at the Arizona State University. Thank you.
Okay, well, it's a great pleasure. I hope everybody can hear me. I should be able to get an invitation to get control over my slides, which I don't see yet.
Let me see. I sent it.
Okay, now I can control it. Let me see. I'm clicking on the screen, but it's not. Okay, it's advancing. Is it me advancing it? Yes, good. All right. So let me try to go back. Okay. So yeah, muchísimas gracias por esa oportunidad. Thank you very much for giving me the opportunity to present this work together with Pepe. Also, special thanks to our deans who have done a fantastic job to give us the big picture, the big vision behind not only BRAIN, which Tech Monterrey, of course, is very familiar with, but most importantly about the support that our institution have been giving us over the years and will continue to give us as we move forward to phase 2. So, okay. So this is a, oops, I think there's a bit of a delay. Okay, so this is the slide I wanted to show you. This is I'm gonna go a little fast because people already has given the picture of the whole center. So I'm just gonna tell you a little bit about ASU beyond what Kyle already mentioned. So we have roughly 30 faculty at ASU that work across multiple schools, not just biomedical engineering where I reside. You can see, you know, EE, computer informatics and decision systems, etc. And like Pepe, we've also been fortunate to have been supporting a number of RU research experience for undergraduates at the ASU site over the years. We're now sending another application, I believe tomorrow, for other 7 students. So this has been really an exciting part and component of BRAIN, which is again training, engaging students, and with particular focus on underrepresented minorities and women. And so we've been, you know, it's been a very exciting kind of adventure in the last 5 years, and we're looking forward to the next 5 years. And this is our outcomes of the first 4 years. We're now in the middle of year 5. There's a number of publications, as you can see, a large number of funded projects. So these are projects that were kind of incubated within the center. And then faculty and industry went out and did other things with those data. And as you could see, we've been very, very successful in getting also extramural funding. We also have 3 in-kind projects, and we also have 3 pending patents in the making. And let's see if this goes forward. Okay, so these are 2 current projects that have been performed right now at ASU. One is one of our faculty from Lockhart and with our partner Core, actually 2 partners, and then the second partner is a startup called Movement Interactive, and they're looking at the effect of low back pain, spinal injection on activity of daily living and gait imbalance. This is the strength of our school. Then on the right, you see a project that is a collaboration with Medtronic that happens to have a site in Tempe, you know, very, very close to our campus. And this is using EEG and FNIRS as a closed-loop control of deep brain stimulation, which has application for Parkinson's and other neurodegenerative disorders. And we also, as part of the philosophy, so to speak, of NSF and why NSF wants to fund this kind of Iucrcs, a big component is not just to have funding that goes into one site and one site with its faculty just engaging local industry, but what NSF really wants is to have the big project that span across multiple sites. As the paper showed, now we have not just 2 sites. We started with UH and ASU, but now we're kind of exploding. We're adding 3 sites in the US. There is a site which is international. We're going to look, at additional sites over the near future. So what that means is that we multiply the opportunities for collaboration, larger projects, larger synergies, exchange of students, ideas, and so forth. So we're entering, we kind of went through almost baby steps in the first phase, but now, as you can see, we're much more mature from the perspective of not just size, but also know-how and ability to connect faculty and industry partners with each other. And so this is an example of project that we propose for phase 2, which engages ASU, the Better Neurological Institute in Phoenix, which is the #1 center in the US for deep brain stimulation surgeries, and also Tir Memorial, Herman, Fuller Intelligence, the company that supports ASU, and Harmonic Bionics, which is a partner of UH. And the idea here is to really establish in a kind of controlled manner the extent to which conventional physical therapy can be improved by robotic therapy. You know, what are the strengths and weaknesses of each kind of approach? And let's see. Okay, so these are our recent accomplishments. We have an award that one of the faculty mentioned earlier. Professor Lockhart just got a grant from the Consumer Product Safety Agency. And then I was also awarded, together with my collaborators at the Mayo Clinic in Minnesota, a clinical trial R01 to look at the comparison between a commercial hand prosthesis and a research prosthesis, which is developed at the Italian Institute of Technology. And the project just started literally a few weeks ago. So these are 4 of the currently funded students funded by an REU. And they've been instrumental in advancing a lot of the brain-related projects, including modeling of ultrasound simulation in brain tissue, looking at motion tracking for a system that we patented for preventing overuse injuries and related kind of topics. And this is a nice picture of everybody smiling and happy. This is the, as Pepe mentioned early on in that org chart, we not only have an industry-led advisory board, but most importantly, we also have a student-led association. This is the ASU contingent. As you see, it's fairly rich and diverse as far as the stage in which the students are in their graduate career. And they're also very, very active and engaged. They come to the meetings and they give us, feedback on the project, and they want to be engaged in different, in different components of the center activities. And last but not least, these are the PIs, the leads of each of the new sites coming up for phase 2. David Frakes is an ASU alum. He worked for Google, then he worked for Apple, and now he's back at his alma mater at Georgia Tech. And he's also been extremely eager and motivated to push Georgia Tech and lead it as one of the new sites. Also, Ramana Binjamuri, who is now at the University of Maryland, Baltimore County, who's also took the lead in getting a planning grant like David Frakes did to basically push also UMBC as a new site for brain. And also we have Peter Conrad, who is also the PI at the West Virginia University site, which is also going to join us in phase 2, which we should hear around December about the funding decision by NSF. And I believe this is my last slide. Yep, this is it. Thank you very much.
Thank you, Professor Marcos Antelo. Now I ask Professor Jorge Jesus Lozoya to take the microphone.
Thank you. Let me just take the control.
That's you.
So please put in the first slide. Contact. Yeah, thank you everyone for being here. Grazie tante, mio amico Marco Santello. Gracias, Pepe, for all of this work together with Marco and all the colleagues. Thank you, Deans, from being here and to be very supportive in this initiative. So I would like to introduce the state of our new ISRC Brain Tech site. Firstly, I'm Jorge de Jesus Lozoya Santos, professor from Mechatronics Department and director of Brain Tech site. I have been working strongly and consistently, mainly on mechatronics, system identification, control engineering since 15 years ago. But since I was a child, the idea of an humanity using the technology for the creation of a better world was very, very strong. So today, being a professor at Tec de Monterrey and the director of this Brain Tech site allows me to serve the society and becoming an inventor. So the mission of the Brain Center at Tech, we will develop safe, effective, and affordable biometric systems to generate added value for companies and communities in the field of health, industry, marketing, education, and mobility, to the creation of new services and processes to increase the competitiveness of the core business and the safety and quality life of the people. So the history of a brain tech. We have been working since 2018 with the efforts of Professor Sergio Uribe and Rogelio Soto. When Pepe Contreras was distinguished professor in TED Monterrey, he helped us to enable the preparation of ideas and the structure for the ICRC Brain Tech site. In collaboration among Pepe in Houston, Sergio and Rogelio achieves the approval of this new site tech. In 2019, the School of Engineering and Science from TED Monterrey, through Ricardo Ramirez, invited me to participate and be part of this exciting initiative. Since then, we have been working tightly with the University of Houston and ASU to consolidate us as the brain site in this great network. Today, we have 3 industrial advisor members: Matching Care Industrial Services, Stability, and Helical. I thank your trust in TED Monterrey. Yes, next, please. So, Brain Tech site complements strongly the school engineering and science strategy. As a center, we will focus on the integration of biometric systems to add value in several technological fronts and commercial solutions. Mainly, we will work on the cyber technologies and working tightly together with nanotechnology, nano devices, and machine learning and artificial intelligence. We will research, develop, and validate technology in all the technology readiness level scale, from applied research and proof of concept to commercial prototypes. The architecture of our biometric system considers the digital transformation technologies integrated with biometric system. The environments of test and validation will consider laboratory simulation and relevant environments. Next, please. So these are our numeralia or numbers. So the state of research activities from 2019 to 2021 can be summarized as you can see here. It's important to emphasize that our main force and of all these results that you can see are very based and supported by our students' collaboration with our professors to solve the needs from industry and creating innovative solutions from academy to industry. Here, you can see our main projects, current projects. In the right side, or in the left side of the screen, you can see the project with Matching Care Education. It's about the detection of engineering interest on children through an intelligent system using biometric science. So here we will use, we are using some brain systems to capture all the biometrics from wearables in the wrist and in the brain. And then through the machine learning system, we will infer about the patient and the interest of the children in some engineering disciplines. The reactive physical spaces for a better human experience and performance is a project with Stability. And this project is very focused on the changing of the perception of the space through some biometric system interacting with the people in these spaces, but changing all the illumination and the color in order to study and improve this experience in this space. Before, Mauricio, please. So we have two principal investigators, Miriam Alanis from Tech, working with Jorge Murrieta every week. Also, our principal investigator, Iucrc Capetillo, working each week with Luis Mille from Stavin. Next. So also we have innovation projects. Innovation projects are those projects that are born from the mind of the professors, and then we have the opportunity to offer to the industry. One of the first projects is the biomechanical models of forces for athletes. So the principal investigator is Gerardo Presbítero, and Mauricio Ramirez also is the program manager, Mauricio, and me. So we are using vision systems to understand and to estimate the motion of the athletes in order to create intelligent coach that supports the coaches to have the athletes to improve the performance. The other project is the Pivot. It's an autonomous robotic platform for safer space monitoring. So I'm the PI, but we are working together with Jorge Murrieta, also Matching Education. It's a collaboration also with Campus City Initiative in Tec de Monterrey. And the Pivot is a solution that borns in the very beginning of these pandemics for a delivery solution, last delivery mile solution. But with the pandemics, it becomes a robot for the service of humans. Yes, mainly to help the security and health services to create a safer and a healthy environment through monitoring of the use of face masks, social distancing, and other things. So this is our current research team, Jorge Murrieta, Luis Enrique, and Angelo Raimondi. They are our industrial advisory board members, our program manager, Mauricio, and our current principal investigators are Gerardo Presbítero, Miriam Alanis, Iucrc Capetillo, and Mauricio. So, thank you. The next one. We are glad to share also this initiative with our faculty. Here we have a rich and deep experience in several applied research topics, like biomechanics, biomechatronics. In this manner, we are waiting for the inclusion of several initiatives. Most of this professor has his own labs and his own network of collaboration. So Brain will help to consolidate and extend its activities to connect his work with industry. Also, I want to emphasize that we mainly work with undergraduates and also some graduate students. In the last 2 years, we have been producing more than 15 conference papers. Also, we have been participating in our Connection Tech. It's like expo from engineering projects from students. And we have been producing also with them 3 journal papers in NDPI. Thank you, students. You are the mind and the main force behind our efforts. So in the recent accomplishments, the Pivot and Digital Twins projects wins in Connection Tech. We got three main positions, second place and third place. And also in another initiative from Tech, we have 3 outstanding Tech students, Karen Lisa Rodriguez Hernandez and Diego Mauricio Botín. They are very active in our Brain initiative. And also, I want to emphasize they are in early semesters, in 5th and 6th semesters. So we expect more collaboration with them. So this is our main result, and it's our pleasure to present it. This is our book, Biometric Trend, Technology and Applications. So we begin to write this book 1 year ago. The goal is to create a first book and strengthen this initiative. The research experience and results, as well as the authors of this book, were very excited about it. The book was accepted for publication last December 2020. So I want to thank to Ricardo Ramirez and all the team for the support and the commitment to have this great result. Thank you to all the co-authors. The main contents, as you can see, are the biometric systems, the trends, the application technology, but also we will focus on the mandatory anaphylactic encephalopathies and children's, the brain-computer interfaces for the use of these as solutions for some system as a system navigation systems, also for the human rehabilitation and human performance. Finally, the use of machine learning, deep learning, and artificial intelligence for diagnosis, seizure detection, and data-centered medical decisions allows to show the main core of our new center with the participation of our faculties. Thank you. Finally, this is our group. This picture is from May 2021. Thank you all. In the next and close future, we will enable the student association, brain student association. So we will begin to collaborate strongly and consistently with the student associations from ASU and Houston University. Thank you all.
Thank you, Professor Lozoya Santos. Now it's time for the Q&A.
I would like to invite you and remind you that you can share your comments and questions in the chat, and Esther Aime and I will be gathering them to the professor to answer them.
Thank you, Aime. Maybe we will keep in touch with all the questions and interest on this initiative. And so we will keep in touch. Aime, please continue with the program.
Well, if there is no questions, we would like to thank each one of you for being here in the launching of the Iucrc Brain Tech Initiative.
This initiative gives great value to each university since it allows closer ties of scientific collaboration between the participating universities.
Each of these institutions will be greatly enriched due to this scientific collaboration, but above all, the ones who will benefit the most will be us, the students, since we will be given the opportunity to continue learning and researching hand by hand with well-known professors and being part of the impactful projects. Thank you.
Thank you. Thank you, everyone.
Thank you, everyone.
Thank you. Thank
And
you.
welcome, bienvenido Tech Monterrey.
Thank you.
Excelente.
Thank you, Marco. Thank you, Pepe.
Thank you, everybody. Thank you, Deans. Thank
Bye-bye.
you, team.
Thank you, everybody.
Bye-bye.
Bye-bye.
Bye-bye.